In this video, we're gonna cover the right use of access modifiers. We are also going to discuss how to use encapsulation properly. We're gonna talk about the virtual and override keywords as well. We're gonna talk about abstract classes and when to use them. And we're also going to talk about interfaces and when should we use them. Let's talk about access modifiers. When we create a class, by default, all members become private. That means that those members can only be accessed from inside the class. Public members can be accessed from any part of the code. And protected attributes and methods can be accessed from within the class declaring the protected members and from all the classes derived from the current class. In order to implement the encapsulation concept of object-oriented programming, the good practices are to declare all our attributes as private and then declaring public methods to access that data. In that case, you are going to have the control over what can be accessed and how the data is modified. This concept, as I've mentioned, is called encapsulation. Encapsulation provides to external code limited access to object members. As I've mentioned before, since attributes can only be accessed through a getter method, you get the control on what object data is exposed and how it's exposed. And when I talk about how it's exposed, I mean that you can add formatting, for instance, in the getter method so that a given attribute is returned as all capitals or following a parsing rule. And since the object attributes can only be modified through setter methods, it means that you can create read-only attributes that can only be accessed through a getter but cannot be modified because an object attributes can only be modified through setter methods. And object attributes can only be modified through setter methods. That means that you can create read-only attributes. You can easily do that by only creating a getter and not creating a setter for a particular attribute. If we go back to our person class, you remember that we have a private member here, which is the name. As we have just mentioned, this is the best practice. Remember to put all your attributes as private and then declare public methods to access those attributes through a getter and a setter. Here we can see an example of a getter name. Here we have an example of a getter method. Here we have the getName method. As you can see, this method returns the name string attribute. We have another method which is a setter. We have the setName method that receives a string parameter and sets it to the name attribute. As I previously mentioned, if you don't declare the access modifier of an attribute, by default classes consider all members as private, as opposed to struct that consider all members as public. Another thing to note in this code is that all our methods start with capital letter, and that's a C++ standard. Other thing to note, as we mentioned in a previous video, is that our attributes start with an underscore. There are many C++ conventions on how to name attributes. The most used are either putting an underscore before your attribute name or putting an M before your attribute name. And the reason why we do that is because we want to distinguish our class attributes from our local variables. Let's now talk about virtual methods. If you want to create a method that can be overridden from a derived class, you have to declare that method as virtual. There is a concept that is called pure virtual method, and those kind of methods need to be implemented by descending non-abstract classes. In summary, pure virtual methods are just virtual methods initialized to 0. And I'm gonna take a second to make this clear. When we create a virtual method, we can declare a body, and that body is going to be used within the class it was declared. The derived class can override that declared method. But when we are talking about pure virtual methods, we're talking about methods that are equal to 0 and that don't have a body. So if a class has at least one pure virtual method, we consider that class as abstract. and we cannot instantiate an abstract class. And think about it, if you have a class called vehicle that has a method called move declared as pure visual method, it wouldn't make any sense to instantiate the vehicle object because vehicle is an abstract class. The reason why we create a vehicle class is because we want to create a car class and a plane class that are going to be classes derived from the vehicle class. And those classes, car and plane, are the one who are going to override the move method and are going to define how does a car move and how does a plane move, giving room to an object-oriented programming term called polymorphism. It means that we can declare a method that receives a vehicle and I can pass either a car or a plane to that method. If all methods in a class are pure virtuals, it means that the class is considered as an interface. In C++, interface is not a keyword. Here we have the vehicle class. We have a protected attribute name, which is called name. Protected means that this attribute is going to be accessible inside the vehicle class, but it's also going to be available within the derived class. Here we have two public methods that have been declared as virtual. Here you can see the getName function, which is virtual, and we have the move method, which is also virtual. We can see a difference between getName and move. Here we see that getName has a body, while move doesn't have a body. This virtual function has been initialized with the value of 0. The difference between these two functions is that getName, even though it's a virtual function, it has a method. It means that derived class are going to inherit this method, but they have the option to override this method. In the case of the move function, it means that the derived class has to implement the method because there is no local implementation of the move function. So let's see the implementation file of this vehicle class. Here you see that I just simply include the vehicle.h header file, and here we see that we have a constructor. The constructor here does a simple thing. It just receives a string attribute, string parameter, and here we're saying that the attribute name is equal to the name parameter. Here there are some few things that I want to point out. We've mentioned this before, but I want to say it again because this is important. Here you see that we are using the std namespace. Here we're saying that we're using the string that is contained inside the std namespace. Of course, we could have said that we are going to use the namespace std by writing using namespace std, but that is not considered a good practice. Because let's say that you are using different libraries like Boost or Qt. Those libraries also define a string class. If I use the using namespace keyword, it's not going to be evident which string I am using. So that's why we normally don't use the using namespace keyword. Okay, so now let's go to our class car. This car class is a derived class from the vehicle class. As you can see here, we're saying that this class is a derived class from vehicle. And here we can see again those two virtual functions. We have move, which we are specifying that it's being overridden, and we have getName. One important thing to mention is that the override keyword was introduced in modern C++ in the C++ 11 standard. Even though it's not required, we strongly recommend you to always use override keyword when you are overriding a method. In that way, it's going to be more evident to the people who is going to read the code, and also the compiler is going to ensure that the code is doing what you think it's doing. For instance, if you think you are overriding a method, but you are really not, let's say that you forgot to route a parameter to that function, the compiler is going to tell you that you are not actually overriding that method. So that's why it is considered a good practice to always write override when you are overriding a method. So here we're going to pass to the implementation file car.cpp, and there are two things that I want to point out. First, that we are actually overriding a pure virtual function, which is move, and that we are also overriding a virtual function. And let's make this difference clear. When I talk about pure virtual functions, we are talking about functions that are equal to 0. That's the terminology that it's used in the C++ world. Pure virtual function is just a function that doesn't have a body. Okay, so let's go to the implementation file of the car class. Here you can simply see that I'm implementing the move method of the car class simply by printing out that I'm moving as a car. So the logic behind this is that every vehicle is going to implement their own way on how to move. I already have a car class, but I could have a boat class and a plane class. Those two classes are also going to inherit from the vehicle class, but of course they're going to implement their very own way on how to move. That's what we want to make clear here. And here I've just overridden the getNameGetter function, and in order to make it clear that I'm overriding the getName method that was originally described in the vehicle class, I just added this string. It says my car name is, and then the name given to this class. Other thing that I want to point out before actually compiling and running this code is about the constructor inheritance. Here you can see that I am defining a car constructor, but it's not evident, it's not implicit that cars are going to have a constructor method that receives a string, even though the vehicle base class had a constructor that receives an std string. It's not inherited in the car class. If you have a constructor that receives a parameter, it is not going to be implicitly inherited in your derived class. That's why I had to explicitly create a constructor here that receives an std string. And the only thing I did in order to call the constructor on the superclass, on the base class, was to name the class and inside parentheses pass the attribute or the parameter that I want to pass to the super constructor. When we talk about superclasses in C++, we talk about base class. If you come from a Java background, you are used to the super keyword to refer to the superclass. In C++, we have a multiple inheritance scheme. That means that a class can be derived from more than one class. That's why we don't have the super keyword in C++. Instead, we have to write the name of the base class that we want to call its constructor. Okay, so after seeing the implementation file for the car class, let's go to the main.cpp, which is the file that contains the main function. So here you can see that I simply include the car class header, and since I've included this header, I can instantiate the car class. Here I'm creating a car object, which is an instance of the car class. And I'm passing to its constructor a simple string. It's called PackedCar. After creating the car, I'm just calling the move method. And after calling the move method, I'm just printing out using cout the name that is returned by the getName accessor. What we expect out of this example is that we're going to see a message in the console that is going to say my car name is packed. And the reason why we are expecting that is because this method, this getter to the name attribute, has been rewritten here in the car class. Lastly, we would like to show you the simple make file that we are using to build this file. Remember that in the last section of this course, we're going to use CMake, which is a modern build cross-platform tool. But right now, we are just using makefile, which is a simple file that we use for the make build system that has been used for C++ for decades. It's simpler than CMake, and of course it has more limitation, but since we just want to build 3 files, it's simpler than using CMake. So the first thing that we've made here in the make file is to create an src variable. Here we're passing the name of the source code that we want to build. In this case, vehicle.cpp, which inside it includes the header file. And the same thing with car.cpp. Those 2 classes are going to be compiled to vehicle.o, O stands for object, and car.o. So here we are creating one simple target, which is all. This target, the all target, it's going to be invoked when I call the make command. I can create custom targets like clean, like install, but I'm just using the default one, which is all. And we're going to have 2 steps here. The first step is to build all the classes, in this case vehicle and car. Here you see that I'm calling the G++ command. I'm passing a parameter to the compiler saying that the C++ standard that I want to use for this project is C++ 14. The -c flag, it specifies that I just want to compile. I don't want to link against the operating system. So this is the first step, to build all the classes. In the next step, I'm calling again the G++ command. I'm saying again that I want to use the C++ 14 standard. And here I'm passing the obj variable. The obj variable is just going to tell the compiler where are the compiled version of my 2 classes, vehicle and car. And then after using those 2 compiled objects, I want to compile main.cpp. The .g flag tells the compiler to add in the debug hooks so that you can plug the compiled program to your debugger. Lastly, we are using the O parameter, which stands for output. It means that the executable that is going to be created, it's going to be called main. So let's run this. So here, after I've executed the make command, here you see that this was executed, G++, std C++14, compile vehicle cpp and car cpp. That was the first step. Then the second step is to build using the C++14 standard the main.cpp, but using the already compiled vehicle and car and given an output of main. After building this solution, I'm executing the output file, which is main. So as we were expecting, 2 lines were printed out to the console. The first one was one line saying that I'm moving as a car, And the second one is a line that says that my car name is PackedCar. So that's how we use virtual functions. And remember, it is a good practice to always write the override keyword every time you're actually overriding a method. In the next video, we're gonna solve common C++ specific object-oriented programming issues. Stay tuned. If you did like this video, please subscribe to my channel, click on the bell so that you receive the notifications every time I upload a new video, and hit like and share it on your social networks. See you in the next video.